Your screen is visible. You can go ahead, Jindong Shah.
Okay. Hello everyone. My name is Jindong and thank you for joining for my presentation today. I'm excited to talk about a project that I've been working on, and it's called uh, a smart robotic system to ensure safe and precise meat cooking using artificial intelligence and computer vision. But I like to call it the automated robot cook for short, or ARC AI. And in this presentation, I will walk through the problem that I have identified and how I created a solution using AI, the process of developing the robot, the results from different experiments, and where I see this project going in the future. Now let's dive in. So there are many problems with current cooking methods for meat specifically. So we all know that cooking can be very time consuming, especially when managing multiple tasks at once. In today's fast-paced world, people are looking for ways to cook efficiently without compromising on quality. The kitchen is often one of the most intensive spaces in the home of people and regular people just like you and me. So people would spend a lot of time trying to prepare food, and mistakes can easily happen from undercooking to overcooking meals. And this is a very common issue that both professional chefs and and home cooks face. And it can lead to wasted food, inconsistency in results, and overall inefficiency. My project aims to solve this by automating one of the most routine kitchen tasks, cooking. And my project also uses artificial intelligence so that it can make sure that meat is cooked consistently and safely so that it can manage to handle different meat and different and at different temperatures so that you could have your desired result at the end. For example, uh like the different types of steak rarities, for example, like rare, medium rare, and well done. So why does this problem matter? Well, this problem matters because there are many time constraints in cooking nowadays, and there has also been like many smart homes that have basically risen in the past, I think, 10 years, and it shows that smart homes are more paid attention to by most people nowadays, and also smarter kitchen solutions are also higher demand. As a result, this my robot could also help people automate cooking and lead to a more consistent and efficient cooking stage in everyone's lives. All right, so the solution overview. My solution is the Arc AI, which is an AI-powered cooking robot that can flip patties, control cooking time, and monitor the different heat levels to deliver perfectly cooked meals. And the Arc AI automates many of the tasks that would require manual supervision, making the cooking process fully automatic and making it faster, more efficient, and less prone to human error. The integration of AI ensures that decisions like flipping a patty at the right time or adjusting the heat are done based on the real-time data, ensuring consistent quality. And here you can see the materials that I've used for my project, including a Raspberry Pi for the main computer. And this is the overall robot and what it looks like. And then finally, you have the linear motor, which is for moving up and down. And I coded the whole robot in Python. So how does my robot work? So you can see right here, this is a kind of diagram that showcases the robot's basic main function. And it basically reads an input of the camera will read the meat and it can identify the parts of the meat that are undercooked, overcooked, or just well. And then there's also a temperature camera or thermal camera that can help identify the meat's temperature, exterior temperature and interior temperature to make sure it's perfectly cooked. So to achieve this, I also used stepper motors and linear motors to control the robot's movement. The stepper motors allow the precise control so that the robot could move in small and incremental steps. This is especially important when flipping food or adjusting the cooking surface. Sensors such as the limit switches and and different switches throughout the robot, as you can see here, they help provide feedback on the robot's position, ensuring that the robot doesn't overshoot or undershoot its target when it's moving up and down or flipping. Additionally, temperature sensors can help regulate cooking, ensuring that meals are cooked evenly. All right, now let me show you a short video demo of the Arc AI in action. In this video, you will see how the robot operates from flipping patties, adjusting cooking times, to regulating temperature based on feedback from its sensors. You'll also notice how smoothly it can transition the process flows without any need for manual intervention. All right, so now let's go to the video. So I had to speed up the process for the video because it'll take too long because normal cooking time for patties is about 7 to 8 minutes per side. And here you can see the finished patty. And yeah, that's the video demo for my Arc AI. All right, so next I will talk about the different experiments that I used for this for my cooking robot. So to test the to validate the cooking robot's efficiency, I set up two main experiments where I compared normal cooking times with AI enhanced cooking times. I ran three different trials using the same type of food, patties in this case, and each time under controlled conditions. The goal was to see how much the Arc AI could save compared to traditional methods in timing and precision. So experiment number one, I mainly focused on the precision of the Arc AI robot. And as you can see from these two graphs, you can see that the Arc AI was able to identify the meat and see if it was undercooked or overcooked. I was able to do this by training a model on the website Ultralytics, so that way the Arc AI could be able to process images and then increase its accuracy. As you can see right here, it has a 99% accuracy that it is undercooked, and then 98.5% 0.6% accuracy that is also undercooked. So that is a really good accuracy score. So that way it can ensure that the robot can identify the status of the meat during cooking. And here, the different experimental tables show that show the different stages of the AI during testing. And here you can see at the start, uh, parts of the AI can can identify it really quickly, and you can see that it remains very consistent throughout when the time goes. And yeah, this is how I measured the precision by using the data from the AI to help me identify the efficiency of the overall ArcAI robot. And here you can see my results, and you can see that precision also increased by 85% to compared to manual flipping, because the consistency in cooking for manual cooking is going to be less than the consistency of normal cooking of my Arc AI cooking. And you can see from this picture, you have you have the different flame temperatures, and you also have the different temperatures for the patty. And these were all test details that I had to use so that it can ensure that the patty was cooked perfectly. And I could also have room for error. For example, this one was burnt, or and then this one was undercooked, and this one was overcooked. So experiment number two, you can see that experiment number two is mainly about overall cooking time and how it can be reduced through my Arc AI robot. So as you can see from the table, Arc AI was able to reduce cooking times across all three different trials. The normal cooking time in trial one was 20 minutes, but the Arc AI reduced this to only 10 minutes, cutting the time in half. In the second trial, normal cooking time was 15 minutes. Was 15 minutes, but Arc AI reduced this to only 8.6 minutes. And then the third trial, the normal cooking time was 25 minutes for a well done slice of a patty. But then my Arc AI was able to bring it down to only 12.3 minutes using the correct monitoring and the correct identification of the meat status during cooking. So the consistency of these three results across trials shows that the Arc AI can automate significantly and it speeds up the process very well. And here is a bar chart that I have. You can visualize the different time savings achieved by Arc AI in comparison to normal cooking times. As you can see, the Arc AI consistently outperforms the traditional cooking methods and times, cutting down the time by almost half. This level of efficiency could make a very huge impact, especially in commercial or households uh, that have time as a limiting factor in their everyday lives. So there's very uh, So for my future development, there are many key ways that I could also include in the Arc AI, including building the Arc AI in many different stages, which can eventually help me. And I would say like my main future development for the future is probably going to be expanding the robot to cooking more different types of things, such as like vegetables, or even like other different types of meat, for example, like pork and chicken. And improving AI for better adaptability is also very important, because that way my AI could make sure it has a higher accuracy, and it could also cook faster for different types of foods, which can improve cooking and cooking in the kitchen way more than now. And I will also, this is a minor one, but I will also integrate the robot with voice assistant and control, so that people can kind of like chat with the robot during its cooking. So that way it is completely hands-free, and it'll be very efficient that way. And I also want to say, for future development, I can also expand this fully to everyone and the community. For example, maybe in the future, there could be like a cooking robot on the public grills in like different parks and community parks, and those cooking robots can help people who want to barbecue or who want to eat in the park, and that can significantly help them by reducing their time and allowing people to have more leisure free time, so that way cooking can be really fast and easy. And I also did some comparisons with different other solutions. So in my research, I found other methodologies that also tackle the automation in the kitchen, but they also fall short in several different ways. One method used was present timers, but there was no AI feedback, and that led to the inconsistency when cooking different foods. Another approach used the machine learning but lacked necessary hardware precision to make micro adjustments during cooking. Finally, some other commercial solutions only automated portions of the process, like heating, but it didn't really handle complex tasks like flipping the patty or adjusting temperature on the fly. The ARC AI system improves on these methodologies by combining AI and precise hardware components to manage all aspects of cooking. So of course, my robot will have many limitations and places for improvement. For example, during during the making of this project, first designing the hardware setup, including the motors and actuators, was pretty difficult because I had to know where I would place these different like components of my hardware so that way it will actually work. And I also worked on integrating the sensors to provide real-time feedback for the cooking process. And it was also difficult because real-time sensors require more coding so that way the robot can actually have eyes and see how how the meat is cooking during its status cooking. And I would say that while the Arc AI has many significant processes that have been already made, there are also many limitations. For instance, the current system is only limited to flipping patties and similar flat foods. And additionally, the AI is trained on a small data set, so it means that it might not perform as well if it had more complex or varied recipes. So to address these limitations, I plan to expand the data set and improve the hardware to handle a wider range of cooking tasks. And in addition, more complex multicultural meal options could increase overall adaptability of my robot and also have a wider audience. And that way it can be used throughout the world. So overall, my Arc AI robot offers a glimpse into the future of automated kitchens with its ability to drastically reduce cooking time while maintaining consistency and quality. And this has the potential to revolutionize the way we prepare and cook meals. And this project demonstrated that AI-driven cooking is not only feasible but also highly effective in different types of cooking. While there are still areas to improve, Arc AI is a strong foundation for the future and kitchen automation. And even though this project includes Arc AI and also many different artificial intelligence components, I also had many challenges that I had to face during the development of the robot. For example, one of the biggest challenges was the precise timing required for flipping food. Because during the prototype of the robot, there was often a big delay between the AI when the AI predicted the optimal flipping time, and when the robot actually flipped the food. And this led to many inconsistent results, which I solved this issue by refining the communication between the two cameras and also the sensors and stepper motors to eliminate the delay. This overall improves overall consistency and less error, which can be very damaging to the system. And it basically shows that my Arc AI can cook more consistently than normal human cooking.